Hi everyone, welcome to the next video. As you can see, like we have a new background, and it's not a new background. I'm at a new place right now. Uh, Anyways, welcome to the new video. So in this one, uh, as you know, previously we were talking a lot about assembly, basics of assembly. So in this video, I want to like kind of progress on it and discuss a bit more about it, some more of the details. So let's dive right in. As you remember, we were disassembling the web server, and I have put in some. We were particularly discussing the handle request part of the code. Last time we discussed till PLT, so like that's linkage table that is there. So I wanted to discuss a bit more things below that is happening in order to give you some more context on how things looks like. Um, so here in this program, I have actually given a break at this particular level, I guess, thing 574, which is like this is the particular line. Here, what's happening is that there is a load effective address. LEA means load effective address. Something is being computed and put into RX. But if I'm just telling it, it won't make much sense, right? So I put it in a breakpointer and we are going to run the program. So I'm just going to run it. Here I'm just going to send the request. It hit the breakpoint. So if I disass it, now you can see I'm kind of there. I think that is the first breakpoint. I think I set a breakpoint at handle request. Uh, but to be honest, right, every time if you're doing this, it's a hassle. Disassing. So there's something called you can see the next 20 instructions by putting in or if you want to put, let's say you want to see the next 10 instructions, you put x/10i, and always the next instruction will be there in the instruction pointer. You can always put $RIP. So that is you will get to see the next 10 instructions. It's a much easier way to see what's coming after each instructions. Let's continue this. I think I have set the breakpoint, another breakpoint there. So if I do the same, you can see that the program is now at line number handle request plus 574. That is where the program is at right now. Uh, so LEA means load effective address. So you can see there is a hex value of RBP. So some value in that variable is being computed and put it into RAX. And you can do NI, that is next instruction, and we can see what's happening here. And if you do info registers, you can see what's there in the register values as well. Um, so this is really cool since this is all hex values right now. It won't makes much sense, but some pointers being like, you can see the RIP pointing to the next line. Uh, See, we are currently at 581. You can get all of those details in. And you might be wondering what is this move Z and test and JNE. So move ZX. Okay, this is a really cool thing. So let's go back to our program right here. What's happening here is that we reach till handle request, parsing of these requests and all of that. But after that, if you can see, this is one of the checks that we were doing for checking the host header to see if there is no host header, then the request has to fail, right? And we can see that we are taking the length of the host header and computing. If it is 0, then it is a bad request. But in assembly, how it looks like is that um, so whatever was in that in that host variable, right? That load effective address is being computed and put into RAX. So it's being calculated and computed into RAX. So there is some kind of an integer value here right now, and you're taking only the byte PTR of RAX, and move CZX basically means you're taking only 8 bytes out of it. So that basically um, represents a value that we are taking in, and we are moving that into EAX, and rest of everything will be zeroed. So we'll have just 8 bytes. That is the very base register. Like, so how registers will look like is that RX will be one register. If you see RX one, the RX is a 64 bit register. Then there is something called EAX, which is a 32 bit, and then there is AX, that is 16 bit, and things like that. And these AL registers, right? AL is an 8 bit register or 8 byte register. Uh, so when we are testing AL with AL, right, we are just computing to see if there is anything there or not. It's a really cool thing that is happening. So, like, this entire check is happening in these three instructions basically. And if it is not zero, then hey, that means there is something there, and we are moving. And if it is zero, it's kind of like, hey, there is nothing there. And and there is another cool thing as well. Look, so you can see the instruction pointer where we are adding a, some random hex value as well. So let's put a break pointer here as well. So that is 604. uh, okay, do I have a break pointer? Okay, I'll put it at 604. Let's continue that. Oh shit. Oh yeah. My bad. Let's send another request. So what happened here was it never reached that portion because the request was totally correct. I think we would have been okay. Oh, I'm not running the program. No worries. I'll quit it. I'll quit the process. So everything is exited. Now if I do disas handle request, you know what? I'll put it in a better place where none of these things break. Anyway, we will have to send back a response, right? So I'll disas the send response, and wherever I'm getting an instruction pointer plus thing, right? I'm just gonna put it maybe, but there's nothing there. Okay. Okay. Let's put it disas. Let me go through the code once and see if something. Hmm. Handle put, handle post. Yeah, this looks pretty good. So there is a host thing that we are checking here, right? Let's maybe break at parse request headers. You might not be having any clue what I'm saying right now, but yeah. Uh, okay. I'm supposed to break at that particular method. So I'm going to break there, and I'm going to run the program. I'm going to send a request in. Where am I supposed to send the request in? Supposed to send the request here. Perfect. It broke over there. Now, instead of showing everything, let's put the next 20 instructions in RIP. Where are we right now? And I would like to show you this particular thing, like, instruction pointer with some random addresses. So what is that? So I'll break at 71. Oh, not 74. and I'll continue. So it hit the break pointer there. Uh, so yeah, so now if I single step in and if I do this as $RSI, it, okay, not sorry, info register. It's a register, man. For registers $RSI. So you have this value. And if you do x/s, that is string of $RSI, right? So you can see something cool like uh uh okay so this percentage SS is being stored somewhere in the memory, and dynamically it's calculating it during the runtime. So that is a pretty cool thing. So whenever you look at RIP plus something is happening, you can kind of think like, hey, something that has been given in the has been given in the program, which is kind of looks like a string, uh, just stored in the memory is being computed there. So it's a pretty cool thing. These are like really nuances of the program. So understanding all of this adds in a lot of value. And finally, in the last video, I didn't discuss one thing, but I want to like show you what these two lines actually happen. So I'll break there as well. That is 451. So I'll continue there. So it hit the next breakpointer. So if I do, uh, I don't. Why are we like let's do x slash 5 instructions $RIP. There aren't 5 instructions, but it's good to see that. See if you do ni um, and if you do info registers, what am I trying to do? Okay, so this particular part of the program is basically the function epilogue, where your entire function has gone through what it has what it was supposed to do, and it's it's setting the stack back in order. So the initial way you set the stack was you're moving the stack pointer to the base pointer. Here basically you are popping off that. So you're popping off the previous RSP and um, bringing in the old base pointer back. So this is pretty important. Maybe we can just do search for function epilogue in assembly. So to get better ideas, yeah, this is a good thing. This is a really important thing because see, the prologue is push EBP and you're putting the stack pointer to EBP and you're subtracting it, which we already mentioned. Now in the epilogue, you're putting back your base pointer to, ESP, and you're popping the EBP out. So hey, it's basically restoring that stacks frame. So this thing, the short of these two steps is leave, and you do return and you get back to the program. So that's a cool thing to know as well. So I guess that's all I wanted to kind of share during this video. It was a short one. Hey, but we are doing more videos, right? So I hope you enjoyed that part. Um, the next part, maybe we can write an assembly program, or maybe we can discuss about some particular vulnerabilities. I'm thinking about other ideas as well. Thank you so much for watching, guys. Take care. Bye.